So today, Stephen Harris, who is ex from JPMC, and I, Sesh Murthy, and the co-founder and CTO of Cloud Raxak, will be talking about container security compliance for financial services. So let me tell you a little bit more about why this is an interesting problem. So we have been working, Cloud Raxak has been working extensively with financial sector companies for some time, especially as part of the Open Cloud Forum, which is a forum where a bunch of banks and financial institutions get together to discuss how to solve problems of moving to the cloud. And one of the key problems that has come up is that customers are very comfortable developing using containers, but they're not sure how to move to production in using containers. And in particular, they are worried about how to move to production while meeting security compliance requirements in highly regulated industries like the financial sector. So we will first talk to you about what are the issues that come up when you move to the production in containers, talking in particular about containers themselves, and then we'll talk about how to solve some of these container security issues. So again, this is me on top, and this is Stephen Harris from JPMC. He's an expert in container security, having used it extensively there. So this is the agenda. So we'll first start with the financial industry cloud requirements. We'll talk about this based on the work that Stephen and I are leading at the Open Cloud Forum in New York. Then we'll talk about what are containers. It's worth revising that because you want to avoid using containers like VMs. What are the security threats associated with that, and how to minimize the attack surface and the vulnerabilities. These three items Stephen will talk about. And then I will get back and I'll talk about how we can automate a lot of what we're doing in container security compliance using Raxak Protect, which is a software product that's put out by Cloud Raxak. And then we'll hopefully have about 5 minutes for questions. So one of the key things that we've been seeing in the financial sector for the last few years is that the customers are interested in moving to the cloud and in particular using containers for flexibility and agility. And the reason that they want to do that is because they are in particular worried about many of the fintechs who are using the cloud and containers to develop in an agile fashion. So if somebody is putting out software releases once a week rather than once a year, then they're likely to beat you in the game. And so that's one of the reasons why the CIO of a large bank put up saying that fintechs and cloud startups are threatening the core banking business by using more agile cloud-based IT. So they want to move there for agility, but what they're worried about is that the clouds in general are not secure, and containers in particular are insecure. And Stephen will talk about some of the issues that come up there, including kernel breakouts, et cetera. So the next thing that's worth noting about the financial sector is, unlike in other areas, you're not going to see a complete move to the cloud in the near future. So traditional IT is going to stay, and several of the banks are putting up dedicated on-premises clouds and dedicated off-premises private clouds for running things like OpenStack, et cetera, VMware. We have seen many of the dedicated off-premises private clouds coming up on top of SoftLayer. We'll talk about why that is, and that's IBM Cloud, because it provides a hardware basis of trust. And the last thing that we're seeing is that financial customers are running with multiple off-premises public clouds. The reason for that is they don't want vendor lock-in. So we're seeing customers using SoftLayer and Amazon, or Amazon and Azure, et cetera. Two of them, different programming models, but it allows you to avoid vendor lock-in. So the key requirement there, if you're going to do that, is to drive a consistent security policy across all of these. And so that's one of the key things to pay attention to when you're trying to look at how to use containers in the cloud. So the containers allow you, they make it especially easy to be able to develop off-prem and to deploy on-prem, because it's supposed to give you the flexibility. Again, so we've been working with a number of these companies, and so we're hearing that they see that containers speed up deployment, but that inconsistent security, it prevents a transition to production. They don't know whether it's secure or not secure, what the issues are, et cetera. And they need guidelines to minimize the attack surface and mitigate known vulnerabilities. And this is one of the things that we're working as a team together to make happen, and would love to work with you on. And the last thing is they recognize that the scale of what needs to be done, automation is required to monitor the security compliance. So I mentioned that we're working as part of the Open Cloud Forum, Stephen and I. There are a bunch of other banks that are participating here in the Security Compliance Forum. And the key aim of this work is to enable the secure use of containers in production. So starting with development, how do you apply a security policy and drive it all the way to production? And the idea is to move proactively to work with the auditors. Is the key point that we need to drive a community-wide consensus for moving containers for production. So if you have a proactive view of what needs to be done, and you can document the best practices, then you can automate the controls. And this is what Cloud Raxak does with the security automation that we do. And that eliminates efforts and whiteboard exercises. So what that does for you is that it reduces cost significantly, and it eliminates the barriers to move to the cloud. So with that, talking about some of the financial sector overview, I'll hand it over to Stephen, and to talk about containers and how they're used in the financial.
Thanks. So before we start talking about container security, we've really got to agree what a container is. For people who just use the things like Docker, they might be confusing the container technology plus the packaging technology and the distribution technology. But at its heart, a container is a set of segmentation of the resources of a shared kernel. So you might have a separate process ID space, file system space, and all the rest of it. Now, these aren't actually new technologies. I was dealing with this sort of stuff 15 years ago. I built out a firewall server and used the Linux vServer patches to create a Bastion host for SSH and for Mail and stuff like that. But modern Linux container technology, using LXC and C groups and so on, is a lot more advanced than what we had before. So one thing you'll notice I haven't put there is that containers are not a security feature. Because they share the kernel, there's a massive footprint, 100-odd syscalls that could be potentially exploited. And the resources that the kernel are sharing out and segmenting may not cover everything. So what you should start thinking of a container as is something with these set of properties. It's transient, so there's no persistent storage there. Your container shuts down, starts up elsewhere. There's nothing that's maintained. So you want to store your data outside of the container, database or an S3 store or something like that. They can also be short-lived. They can run from anywhere from microseconds upwards. And normally you want to have a termination point as well. They may only run for 5 minutes, 10 minutes, an hour, a couple of weeks before you kill them. You don't want these containers to live forever because they're not meant to be VMs. They're meant to be containers. And they're immutable and untouchable. You can never log into these things. You shouldn't be patching containers. You should be modifying the image whenever you have a problem, shut down the bad container, spin up the new container. And that's feasible if you take into account the fact they're transient and short-lived and be killed. And to do all of that, you've got to have a great automation system in place. So instead of looking at a container as another form of VM technology, think of it as something with a whole new set of parameters and attributes that you can use to change the way that you deploy your software. Create an application delivery platform rather than another virtual machine system. And so that's why a container is different to a VM. They're fast, they're dynamic, you can spin up hundreds and shut down hundreds. You can't track them in a normal inventory the way that you do in a traditional compute environment. And if you don't know what's there, how can you patch it? If you come up with another version of shell shock, if you don't know where your containers are running, you're never going to be able to shut them down and fix them and restart them again. There are technology issues depending on what you use. If you use Docker, if you use Cloud Foundry, if you use Appender, they're all going to have their own unique technology solutions to them. The Docker daemon, it runs as root, and if you give people access to the Docker API, the Docker command line, you can let them spin up a container that mounts the host file system. And you've now given them root access to the file system. So again, it's still not a security feature. But SE Linux can actually change the way you do that. It can actually say things running in the container aren't allowed to see things outside of what it's been configured for. It's hard work to do, but it changes it. And obviously, because there's a hierarchy of controls, you've got to make sure that your parent OS is fully patched. So make sure that you patch your kernel, you patch your operating systems, do all the standard stuff you used to. Now the key here is that we're now talking at a totally different scale. You may have hundreds of thousands of containers or even millions of containers that are floating around, starting up, shutting down. The solutions that you use today for your traditional compute environment just won't cope with that. So what can we do now to make sure that the container system and infrastructure you're building now is as secure as possible? First is you start with the kernel. You don't have to use the kernel your OS vendor provides. You know, if you're using Red Hat, yes, it's a nice kernel, but you don't have to use their one. You can download from kernel.org and configure it with a minimum necessary set of drivers that you need. And if you're running your container infrastructure inside a VM, it becomes quite easy and consistent. You know exactly what drivers you want to run. So no dynamic loading, minimum set of drivers. Similarly, the OS that you're running on, if you're a fan of STIGs and the DoD controls, make sure that you've met everything. You know, your operating system has to follow at least your standard traditional compute baselines. You can't allow it to diverge because if your OS is insecure, your containers will be insecure. The mechanism that you use to deploy your containers, you know, if you're using Docker, make sure your Docker daemons haven't been modified or tampered with, the same as you do with any other piece of software. The container image that you run should be one that you know and trust. So don't just pull things down off of the internet and run those. Make sure it's gone through your standard CI/CD processes, that all the content inside these containers has been properly curated, that you've verified the provenance and the licensing are correct, that you've maybe run it through a set of scanning tools to check for OWASP type security and all the rest of it. And the only way you're going to do all of this is to automate everything. You're never going to be able to get all of this done if you keep your hands on. Traditional compute environment, you might get your VM delivered, and then your dev team will sit around for a few months tweaking configuration files to get the server running. You can't do that here. It's got to be all purely automated as part of your build process. So a container has... so there's a life cycle for a container. You know, you've got to build a good container, deploy it in a well-known, consistent manner, make sure that these containers don't have any vulnerabilities, especially newly found vulnerabilities, and then when they've been discovered to be bad, you replace them. How do you build a good container? You should already know how to do this. You should already know how to do this, but unfortunately the dark secret is a lot of people aren't doing this for their traditional compute environments. Their applications aren't being properly done. Now there's a few extensions to follow for the container world. when you build a container, it's tempting to build your Docker instance by saying something like, from Debian Jesse, copy these files over. You've now got a whole copy of Debian inside that container, which you don't normally need. So if you're building something like with Go, you only need the one file, the Go program itself. You don't need the whole OS in there. If you do need to put an OS for any reason, because you're just bringing in RPMs or D packages or something else, then use a consistent image everywhere. Use the operating system that you're already building and securing and maintaining, so you don't have to go and duplicate all your work. And that means definitely don't just bring in random images from the internet, because you've got no idea what the OS base is on there. Again, you shouldn't be pulling code from the internet. I don't know how many people heard of the left pad chaos a couple of months ago. One guy pulled code out of NPM and everybody's build processes broke because they were put in live. You shouldn't be doing that already, but you need to extend this now to your Docker registries. Don't use the internet-based Docker registries. Run your own private ones. Make sure that everything in there has been properly curated. Code scanning tools. You should, again, be using this. Yeah. So everything that goes into your container should go through scanning, go for CVE detections, run through OASP. And this could all be actually automated as part of something like a Jenkins build process. You can check your code into your Git repo or your Subversion tree, and that can trigger a Jenkins build that can push it through your code scanning tools, and only if it passes everything can it then take your final container image and push that into the registry. At this point, humans aren't actually involved in the registry maintenance or configuration at all. It's all done via automated tools. And similarly, when your devs are happy with it, that's exactly the same image can then be promoted to QA and then promoted into prod. So that way you've got a strong provenance of the code that's going into your environment. There'll be no drift. The deployment of containers there's not really a lot here, but it's an important part of it. You should only deploy what has been safe, and your orchestration system has to be the tool that tracks where things are running. So that means that you can't allow people to spin up containers on their own on those servers because you've got no track of it. The advantage of this is that it actually then helps you deploy at scale. If you do need to go and spin up 500 instances because you've got a market condition, everything's already there to do that. You can do it. And you can do your blue green deployments and everything else as an advantage. So there are some big wins by deploying in this manner. CVEs get found in libraries that you've already used. The new bug in OpenSSL is bound to come along next month. There has been every other month so far. But they could be here in your library, in your operating system, in the compiler, even in JVM itself. So just because you've deployed a good image doesn't mean it's going to stay good. So you've got to consistently scan your registry to make sure that all of the images that you've got stay good. And then when you've got them and you know it's bad, now you can determine how you want to go and fix it. If you've got an internet-facing container that has got a shell shock equivalent, you might want to go and replace those pretty quickly. But if you've got an internal-only application that's only serving out public data, you might want to wait 45 days or 90 days, whatever your risk processes are, before you want to change it. So between all of that, that's how you maintain a lifecycle ecosystem for your containers. Now, Seth's going to talk about some of the automation parts of things.
Thanks, Stephen. So we spent about 20 minutes talking about what are the issues that financial sector customers face moving to the cloud and using containers. And Stephen did a great job talking about what needs to be done to minimize the attack surface, especially on configurations. The kernel, OS, container mechanism, the supply chain networking controls. And on the right-hand side, especially around the operational practices. So to automate the operational practices, you will be using a tool like Kubernetes or Mesos or something along the lines to do the inventory management, to set container lifespan, etc. And some of these things, it's just a practice you have to follow. For example, running containers on a hypervisor to bolster security, etc. So we have captured in this one page the summary of what Stephen was talking about on what needs to be done to check and set configurations and operational practices. So what I will now talk about how using the Raxak Protect agentless architecture, you can, the left-hand side, the check and set the configuration so that you can use containers securely. So just to review, when the customers move to the cloud, they don't often recognize that in the cloud, a virtual machine or a bare metal machine on software that you get is typically designed for ease of development and not for secure deployment, right? So a large portion of those security parameters are set wrong. So Stephen pointed out that you need to take a look at the security parameters and check and set them. So if you do it manually, it's slow, error-prone, and increases risk. So Stephen was talking about how you could have 1 million containers in your enterprise. And at that scale, you cannot do it manually. So what you can't check and set manually. So what we do in Raxak Protect is we have the concept of a profile, a security profile, which is applied consistently to the assets on the right-hand side. So let me spend a minute talking about the architecture of Raxak Protect. So what Raxak Protect does, Raxak Protect, by the way, is this is a SaaS service or a on-prem appliance. It's in the dotted box out here. It applies a security profile out here to a set of assets that can span the public cloud, the private cloud, and traditional IT below. So I remember I was talking about that customers are using all of these. So the ability to apply that security policy in a consistent fashion is really important. The second thing that is really important is that you, as Stephen said, you need to automate everything. People will not automate it if it's not simple to use. So the way we make it simple to use is that Raxak Protect is integrated with the service catalog of the enterprise. So when you so a typical service that you have in the service catalog is give me a VM, for example. And what we have done is that we have made it such that give me a VM that's secure. By first calling the cloud, getting the asset, and then applying the security profile to it. We have also integrated with DevOps tools. As Stephen was saying, you need to integrate your security tools into the CI/CD process. The DevOps tools are the critical thing to do out there. That is what you would call as a no-touch deployment, right? Because you're specifying in your DevOps process what your security profile needs to be, all the way from development through to production. So in summary, what Raxak Protect does is it integrates with the existing tools, applies a profile to the assets. It checks the current state of the assets on the right-hand side, and if they're off, then it can go and remedy them. So let's see how we can use this in for some of the configuration checking and setting that Stephen had talked about at the kernel level, the OS level, etc. So what Raxak Protect does is that it applies standard profiles. We mentioned the DISA mission critical profile earlier, and it can apply these profiles from a hardware basis of trust. Let me explain what that means out here, because that's when you are coming in from the outside in this previous chart and checking the status of the assets out here, you are doing that by going and asking the software, the kernel typically, a set of questions. And what you need to ask yourself is, how do you know that that kernel itself has not been tampered with and that it's yielding correct results? So what Raxak Protect does is it works with the hardware basis of trust that's provided by the Intel TXT TPM chips. and uses that to ensure that the machine booted up correctly, the BIOS, the boot files, etc. are okay. And then going up, it then verifies that all the compliance information that it gets is correct. It does this continuously from the boot to end of life. And so that's one of the things that Stephen talked about, which is that it's not enough to just check the things when they start. You need to check them continuously. You need to apply it frictionlessly. That is, it should be easy to apply in a consistent fashion across clouds. And of course, the last thing is the numbers here are large. So people are used to dealing with 1,000 VMs or so inside the enterprise. Well, we're talking of 1 million containers, then driving a scale is critical. And so Raxak Protect is designed to be highly scalable. And I can't get into this right now. The agentless part is, we've done that on purpose to avoid security exposures that come up through agents. So let me walk you through a use case of protection from BIOS to applications that we're working with one of the customers in the financial sector. So coming in from the outside, here, it should be here. Yeah, so you can see the mouse now. So what it does is Raxak Protect goes and uses the hardware root of trust that's provided by Intel to check that the BIOS and the kernel and the boot files are all untampered with. So what this tells you is that, now this machine came up correctly. So that means that you now know that you can trust that kernel. Next, you go in and you use coming in from the outside, you come in over SSH, and you verify that the OS settings and the system libraries are all compliant with the DISA mission-critical classified STIGs. So if you're not familiar, the DISA mission-critical classified STIGs, there are about somewhere between 250 to 400 different security guidelines that they put out. And so Raxak Protect goes through each one of these, verifies that the infrastructure is set up correctly, and that it is that there are no security exposures with which somebody could get in. Next, you can verify that the container mechanism itself has not been tampered with by looking at the signature of that. And then you can go in and look at the container images themselves in the registry to make sure that there are those, you check and remediate any of the settings out there. Lastly, what you can do using the Intel CIT technology is to verify that the containers themselves, when they come up, they are coming up with, there's been no tampering in bringing the container up. So in the process of reading from your signed registry and bringing them up, you want to make sure that no tampering has occurred out there. So this entire process, going from the hardware root of trust all the way up to the containers, what this allows you to do is that you can make sure that all of those settings that we talked about are set correctly. And it reduces the attack surface, and it's possible to then use it. And then along with the work that you need to do using, for example, a Kubernetes or a Mesos, you can automate the operational practices that Stephen talked about, and then you can get the security that you need. So the key here is that Stephen did an excellent job talking about what needs to be done to minimize the attack surface, and that how defense in depth is the key. Based on what Raxak Protect can do in the checking and setting the parameters, the configurations, and what can be done using tools like Kubernetes, Mesos, etc., to be able to do the inventory management and then your source code management, etc., you can meet the requirements of running containers in production. Now, there's if all of the financial sector customers were to work together, like for example through the Open Cloud Forum, and then it becomes much easier to educate your regulators on what needs to be done, so that it doesn't become into one-off whiteboard exercises where you have to explain why each individual thing needs to be done. We believe that this set of best practices that we've outlined out here, automating them is enough to be able to meet the tough financial sector regulations, and in checking and setting things, and then in the hands-free deployment that Stephen talked about, which you could do with things like Kubernetes, Mesos, et cetera. So we think that, it's Stephen likes to joke that containers are less safe than VMs and so on and so forth. And I will quote from one of his statements there that the safest thing is an air-gapped computer, which is at the bottom of the sea, right? But actually, the important thing here is that containers are safe. By using defense in depth, the way that we have described, you can actually use it. You can use the flexibility and agility, and you can make your life a lot simpler and when running the cloud. So with that, if there are any questions, Stephen and I will be glad to take them. Please.
When you talk about mitigating vulnerabilities and applying the API and provide software as a service,
yeah.
What you're eventually doing, you're identifying the known vulnerabilities.
Yeah.
Most of these containers.
Yeah.
Are provided by Azure or CloudSpace or IBM, and then you're making sure that those vulnerabilities do not exist in the container. Outside of that, we have specific policies for access and entitlement, which any organization will want.
So, do you understand the question?
Which type of access and entitlements are you talking about? Well, so inside the container itself.
In the container, you may have like some IDs which connect to backend storage or backend database itself.
Right.
Do you provide specific policies which are fine-grained, which organizations can use as part of the policy? Or is it only for known vulnerabilities?
So there's two different types of access there. So what we've been talking about is a framework for running containers in a secure manner. We haven't really been addressing how developers should develop secure applications that run inside a container. The question you're asking, how to get credentials into an application, is actually a really tricky one, and it will depend on the technology you use. So you might do it one way in Cloud Foundry, you might do it another way with Kubernetes, another way with Mesos. We can provide a form of guidance, and effectively that boils down to having a method of identifying the container that's making the request. But other than that, you're going to end up with a pretty strong turtles problem. If you want to use a password vault, how does your app authenticate to the password vault? Well, it needs a username. So you end up just kicking the can down the road and not actually solving it. So you have to think outside of the container itself and think of how to identify what container is making the request.
Does that answer your question? So, there are a bunch of things that you can do in, for example, network controls, et cetera, that are orthogonal to what you were asking. But, so you can use microsegmentation in the network, use firewalls to prevent the people from coming in. Then you can use, it's under the networking controls. We didn't talk about that. You can use a whitelist for who can call the microservices. All these things can prevent, even if somebody has gotten into your system, it can prevent them from expanding out, right?
That is not the framework which you provide in your API, is my question.
No, so the microsegmentation, for example, you have to do separately, right? We can check that things are set up correctly. Similarly with setting up microservices so that there is only a whitelist of people call them. We can check that you've set it up that way, and if you're not, we can tell you that you've got too wide access for open. And then that would be a finding that you need to remediate. So what compliance does typically is that it'll look at the settings and it'll tell you where things are off. And so this is what we're doing around. Primarily, Raxak Protect works around the configurations, and operational practices you have to build into the existing tools that you have. Yeah, please.
Just, I guess it's a Raxak question.
Yeah.
As opposed to a regular container question, is that I'm trying to figure out is if you're agentless, right?
Yeah.
It would seem some of the queries that you're asking about the container validity,
Yeah.
privileged questions.
Yeah. So
You would turn on and you would get some privilege. You understand something about a container that you might not want to expose otherwise, i.e., what version, library, et cetera, and some non-privileged user. So
yeah.
you
So one of the things is that Stephen brought this up, is that you want to prevent SSH to get into the containers, right? So once the container is up, then it's immutable, and then either you shut it down because you found that the image has got some vulnerability in it that is newly discovered, or you shut it down because it's reached its end of life. Right? So you have an active end of life to shut it down. So we're not advocating going in and looking inside the container to see what it's doing.
I think that when you went through your architecture diagram,
Yeah.
you indicated that it went through and then something got, that container got deployed.
Yeah.
You went through and you validated. I think that's what you
So what the Intel CIT technology does is that when the container comes up, it verifies that the signature of what came up matches the signature of what's in your registry. That's hardware signing. Yeah, that's a signature, and so that essentially you know that the container came up untampered with. That's really valuable because each thing you do of that kind reduces the attack surface, right? So you can cause something to spin up a container that's not in the registry, and you can do a bunch of things. So that's what I was referring to. Any other questions? Yes.
So once you start up this container,
Yeah.
you verify that it started from a trusted image.
Yeah.
How do you verify that what's running in your container at a later point is actually what you started up with?
Okay, so what we're saying is one way to do it is by looking at some of the characteristics of the container. So, I mean, what kind of network accesses is it doing? What kind of access is it doing to the database, the hard disk, or whatever? What kind of access is it? What kind of CPU usage is there? So this is a signature that you can learn about what that container typically does, and it deviates significantly. You can look at that, and by monitoring, and I think it's in there, but I can't see it right now, the container resource utilization monitoring. So by doing that, you can tell what's going on in there. It is really a bad idea to have the SSH daemon and to go in and check what's going on. You want to add to that?
And this is also where microsegmentation can benefit.
Correct.
If you set up a login rule for the deniers against the network, if you suddenly see a container making a load of port 22 connections, you know there's a problem in that container.
Yeah, right, exactly. So that's what I mean by the thing. Any other questions?
Majority of the mechanisms is running on what platform? It's Unix or it's something else?
So,
A lot of what we've been discussing here is effectively not applicable to, it applies to any type of platform. So you could use it for Solaris zones, you could use it for Linux containers, you could use vServer. So the concepts follow across. So if you're going to build out using Windows Nano Server and building out containers on top of that, or running Docker on top of Windows, that would all follow. I've primarily been focusing on Linux containers because that's my speciality.
okay, I think we have run over our time. So thank you very much for coming for the time.